Here we have a problem on solving a system of equations. In the given system of equations over here, we have to find the values of x and y. Okay, now what I'm going to do is I'm going to assign a new variable, say k, for this x over y. Let me do it. Let k equals to x over y. Okay, now let me take reciprocal on both sides of this equation. If I take reciprocal of this k, I am getting 1 over k, and if I take reciprocal for this x over y, I am getting y over x. Okay, now let me consider the first equation over here. That is square root of x over y positive square root of y over x and negative 5 over 2 equals to 0. Okay, for this x over y, I can substitute the new variable k, then I'm getting square root of k positive. For this y over x, I can substitute this stuff, that is 1 over k negative 5 over 2 equals to 0. Okay, here let me keep the terms which contain k on the left side and the constant on the right side. That is, we have to get rid of this one. For that, we have to add 5 over 2 to both sides of the equation. Let me do it. So when I do so, this positive value, negative value will cancel out, and square root of k positive. When I take square root for this fraction, so I can distribute the square root of for the numerator and denominator. So when I take the square root for 1 in numerator, square root of 1 is still 1, and when I distribute this square root of for the denominator, I'm just getting square root of k equals to, on the right side we have 5 over 2. Okay, now let me assume there is 1 in denominator over here, because if I want to add these two quantities, I must be having two fractions of the same denominator. But here the denominator is square root of k, but here the denominator is 1. So to get square root of k as denominator for the first fraction over here, I have to multiply both numerator and denominator by square root of k. So when I multiply square root of k and square root of k, I am just getting k. In denominator, when I multiply square root of k and 1, I am getting square root of k positive 1 over square root of k equals to 5 over 2. Okay, so here we have the same denominator for both the fractions, that is square root of k. We can take square root of k as a common denominator, and we can add the numerators k and positive 1. Then I'm getting k positive 1 by square root of k equals to 5 over 2. Okay, now we can do cross multiplication. That is, we have to multiply the numerator on the left side by the denominator on the right side, and the numerator on the right side has to be multiplied by the denominator on the left side. Then I'm getting 2 times k positive 1 equals to 5 times square root of k. Okay, now to get of this square root, what we can do is we can square both sides. Let me do it. Then I'm getting 2 times k positive 1 the whole square equals to 5 times square root of k the whole square. Okay, here two terms are multiplied and we have the exponent in common. Whenever two terms are multiplied or in division and we have the exponent in common, we can take the exponent for each term and multiply the results. Since the two terms are multiplied out here, then I'm getting 2 square times k positive 1 the whole square. And the right side also the same thing. Two terms are multiplied. We can take this exponent separately for each term. Then I'm getting 5 square times square root of k the whole square. So the value of 2 square is 4, and we can get expansion of the square of the binomial over here using the algebraic identity, that is a positive b the whole square equals to a square positive 2ab positive b square. This is one of the important identities in algebra. So we can use this identity to get the expansion of the square of a binomial in this form. That is, there is a positive sign between a and b. So its expansion is a trinomial over here. So comparing this and this, we have k at the place of a and 1 at the place of b. Now to get the expansion of this one, so we have to use this trinomial. In this trinomial, at the place of a, we have to write k. At the place of b, we have to write 1. Okay, let me do it. Then I'm getting k square positive 2 times k times 1, that is 2ab positive b square means 1 square, and here 5 square is 25, and this square root and 2 will cancel. I'm just getting k. Okay, now 4 times k square positive 2 times k times 1 is just 2k, and the 1 square is just 1 equals to 25k. Okay, now let me erase this stuff and continue the problem. Now we can distribute this 4 to k square, positive 2k and positive 1. When I do so, I'm getting 4k square, positive 8k, positive 4. On the right side, we have 25k. Okay, here we got a quadratic equation, but it's not in standard form. Standard form means we have to get everything on one side of the equation and the other side 0. Okay, now let me make the right side 0. For that, we have to get rid of this positive 25k. So to get rid of this positive 25k, let me subtract 25k from both sides. Let me do it. So when I do so, this positive and negative value will cancel. I'm getting 4k square. When I combine these two terms, I'm getting negative 17k, positive 4. On the right side, we get 0. Okay, here now I think we can try to solve this quadratic equation by factoring. For that, we have to multiply the constant term positive 4 by the coefficient of k square 4. When I multiply positive 4 by 4, I'm getting positive 16. Now I have to get two factors over here, so that the product of two factors equals to positive 16 and the sum of the two factors equals to the coefficient of k, that is negative 17. I think negative 16 and negative 1 will work. When I multiply negative 16 and negative 1, I'm getting positive 16. When I add them, I'm getting negative 17, which is the coefficient of k. Okay, further I have to divide both these factors by the coefficient of k square, that is 4. So when I divide this negative 16 by 4, I'm getting negative 4. Here 1 is not divisible by 4. We have to write this one as it is, that is negative 1/4. Usually when we solve a quadratic equation, we'll be getting two values for the variable. In this case, it's k. So we'll be getting two values for k. Now to get the first value of k, I have to change the sign of the first factor over here. It's already negative. If I change the sign, it will be positive. So the first value of k in this quadratic equation is 4. And now to get the second value of k, I have to change the sign of the second factor. So it's negative. When I change the sign, it will be positive. That is 1/4. Okay, I got two values for k. One is k equals to 4 and other one is k equals to 1/4. Okay, now let me erase all the stuff and continue the problem. Okay, let me write the two values of k. Just now I got it. That is k equals to 4 and k equals to 1/4. K is a variable taken by us. So actually we have assigned the variable k for this x over y. So we know that k equals to x over y. So now we can replace this k by the original stuff, that is x over y. So in that case, I'm getting x over y equals to 4 and here x over y equals to 1/4. Okay, now when I multiply both sides of this equation by y, let me do it. So I multiply both sides by y. This y will cancel. I'm getting x equals to 4y. Okay, here we can do cross multiplication. That is, this numerator has to be multiplied by this denominator. This numerator has to be multiplied by this denominator. So when I multiply this x and 4, I'm getting 4x. And when I multiply this 1 and y, I'm getting just y. Okay, now I got two equations, x equals to 4y and 4x equals to y. Now let me consider the other equation in the given system, that is x positive y negative 5 equals to 0. Let me write the equation two times. Okay, so because I am going to plug in these two results in the other equation, that's why I've written the other equation two times. First, let me plug in this result, that is x equals to 4y. Okay, so here for x we can plug in 4y, then we get 4y positive y negative 5 equals to 0. When I combine this 4y and positive y, I'm getting 5y negative 5 equals to 0. When I add 5 to both sides, I'm getting 5y equals to 5. When I divide both sides by 5, I'm getting y equals to 1. So when now I got y equals to 1. When I plug in y equal to 1 in this equation, I am getting x equals to 4 times 1. So x equals to 4. Okay, now I got that x equals to 4 and y equals to 1. So I got one solution for the given system of equations. Now what we need to do is we have to plug in. So this result, that is 4x equals to y or y equals to 4x into the other equation. Let me plug in y equals to 4x. So x positive, for this y we can plug in 4x negative 5 equals to 0. So when I combine this x and 4x, I'm getting 5x negative 5 equals to 0. So when I add 5 to both sides, I'm getting 5x equals to 5. When I divide both sides, I'm getting x equals to 1. Now we can plug in x equals to 1 over here. When I do so, I'm getting 4 times 1 equals to y. 4 times 1 is 4, that is 4 equals to y. Okay, now I got the second solution for the given system, that is x equals to 1 and y equals to 4. So I got two solutions for the given system. One is 4 comma 1 and other one is 1 comma 4.